And hello, today we'll be looking at algebra factor fundamentals. So before I talk about factors with algebra, I think it's important that we first understand factors just with regular numbers, with natural numbers. And I have a video up already about this, so I recommend looking at that video just as a refresher. But I'm just going to go through what factors are now anyway. As we know, a factor, let's say the factors of 8, we first write out the factor pairs. So, 1 times 8, that would be equal to 8. 2 times 4, that would be equal to 8. 4 times 2 would be equal to 8. And then obviously 8 times 1 would be equal to 8. And the factors are all the numbers that are listed here. So in this case, it's 1, 2, 4, and 8. And these would be the factors of 8. Now, what's a little bit more important, and especially when we're looking at algebra factors, you need to recognize that, these numbers, if I divide 8 by these numbers, I get a whole number as an answer. And they divide in without any remainder, is another way of thinking about that. So let's say 8 divided by 8, that's 1. 8 divided by 4, that's 2. 8 divided by 2, that's going to be 4. 8 divided by 1, that's 8. Those are the only numbers that divide into 8 without any remainder. Whole numbers, sorry. Obviously, you can divide 8 by fractions and things like that, but I'm saying you can only divide 8 by these whole numbers, and you won't get any remainders. So that's kind of bearing in mind when I'm talking about factors with algebra. I'll be mentioning dividing every now and then, and that's where this is coming from. I'm saying a factor will divide into the number and it will come out without any remainder. So, algebra factors. So let's say we're looking at 6xy and 12x. Now it's important that you look at the algebra fundamentals video that I have up, which discusses how we use the operations with algebra. So if I was to write 6xy, looking back on that operations, what does this actually mean? Well, this is just 6 times x times y. And 12x, that's just 12 times x. Now, if we were to write out our factor tree, it would look something like this. So this 6xy is the same thing as 6 times x times y. And 12x is the same thing as 12 times x. Now, x and y, you can't really go any further than that. And x, you can't go any further than that. But what about 12? Well, I can break up 12 into its factor pairs. So 12 times 1, 6 times 2, 4 times 3. And I can break 6 up into its factor pairs. 6 times 1, 3 times 2. So when you're visualizing, what are the factors of, let's say, 6xy, try and picture this. It's 6 times x times y, and what are the factors of 6? And then 12x, it's 12 times x, and what are the factors of 12? That's how we would kind of visualize it. So, this is really important. You need to remember this, because I'll be kind of referring back to this. But what if we were asked, what is the highest common factor of 6xy and 12x? So, remember, I had another video about the highest common factor with natural numbers. The highest common factor is what factor do these both have in common, and what's the highest one, what's the greatest one that they have in common. So how do we do it? Well, first off, let's forget about the variables and look at the coefficients. So the coefficient is the number in front of the variables, in front of the letters. So this is the number 6 and the number 12. So we ask, what's the highest common factor of 6 and 12? Now again, I've looked at this in previous videos. How to find the highest common factor, you just look at the factor pairs. If you're not comfortable with that, I recommend going and looking at those videos. But just thinking about it, what number divides into 6 and divides into 12? So do you remember, factors divide into the number. So what number can be divided into 6 and into 12? And what's the greatest number that can be divided into 6 and 12? Well, it would be 6. Because I can divide 6 by 6, and I'll get 1. And 12 can also be divided by 6. So 6 is the highest common factor of 6 and 12. Okay, now we look at the variables. So I've dealt with the coefficient, or the number. Now I'm going to look at the variables or the letters. So now I'm going to ask, what's the highest common factor of x, y, and x? Well, it's x. Now, why is that? X, y is just x times y. Yeah? From the previous slide with that factor tree, x, y is just x times y. X is just x, there's nothing else, no other letters. So what's the greatest thing that I can divide x and y by and x by? So again, remember factors, you can divide it into both these things. Well, I can divide this by x, yeah, and I can divide this by x. I can't divide it by x squared. There's no x squared here. There's no x squared here. Now, you're probably asking, why can't I divide this by y? Yes, you could. You could divide this by y, but there's no y over here, so I can't divide this by y. What about if you divide this by xy? Well, yeah, I could divide this by xy, but I couldn't divide x by xy. So you have to be careful. You could say, oh, I could divide this by something, but you also have to be able to divide the other variable over here by the same thing. And what's the greatest thing that you can both divide into both of these things? Well, it's x. So then I can rewrite these as, so let's say 6xy, I could write it as 6x by something, and 12x, I could write it as 6x by something. So this bracket means times something. So just using your head, well, what's 6x by something is 6xy. So what's the difference here? Well, 6x by y, yeah? 6x times y is going to be 6xy. And what about the next one? Well, 12x is equal to 6x times something. Well, it would be 2, because 6x by 2, well, 6 by 2 is 12, and then x is just going to be there, so it's going to be 12x. So, the highest common factor of 6xy and 12x, well, it's going to be 6x. That divides into this, that divides into this. So how did I do it? First off, I looked at the coefficients, then I looked at the variables, and then I said, okay, 6 is the greatest coefficient, and then the greatest variable I could divide into is x. So I said 6x is the highest common factor. Now, why did I write them like this? Well, this is what we call the factorized state. So 6xy, if I were to factorize it, it would be 6x brackets, so that's times y. And 12x, I could write it as 6x bracket by 2. So if you're told to factorize this with the highest common factor of both of these, well, this is what you would write. You'd say, okay, well, 12x is the same thing as 6x by 2, and 6xy is the same thing as 6x by y. Yeah, so this is the important slide. I'd recommend going over it if I went a little bit too fast. The main things to remember are, how did I get the highest common factor, and how did I factorize them? Little bit of a trickier example now. We have an x squared and a y squared. So what is the highest common factor of 8x squared y and 12xy squared? Remember, x squared is the same thing as just x by x. So going back to my, where is it, all the way back here, this tree, if this was squared, it would be 6 by x by x by y. So that's, if it was squared, it would just be times another x. Anyway, going back to the slide, where was I? Here. First off, you look at the coefficient, the number in the front. That's what we always do. So what's the highest common factor of 8 and 12? Again, if you don't know, go back to the highest common factor video. Well, it would be 4. Because 4, I can divide 8 by 4, I can divide 12 by 4, and it's the greatest thing that I can divide both of them by. Okay, a bit trickier now. What's the highest common factor of x squared y and xy squared? First off, what I would do is think about it. X squared y is x by y. Xy squared is x by y by y. Yeah, so y squared is y by y, x squared is x by x. Now, what's the greatest thing I can divide this by and this by? So there's an x, and a y, and an x, a y, and a y. Well, it would be xy. I can divide this by x and y, because there's an x and a y in it. I could divide this by x and y, because there's an x and a y in it. I couldn't divide it by anything else. So if I chose, let's say, x squared here, so x and x, I could say, well, I could divide this by x squared. I couldn't divide this by x squared, because there's only one x over here. I could divide this by y squared, but I couldn't divide this by y squared, because there's only one y over here. So the greatest thing I could divide both these by is xy. So again, what do? We combine them. So the highest common factor would be 4xy. So that's the highest common factor of both of these. Now, if I want to write them in the factorized state, which will become a lot more important later, if I had 8x squared y, well, that's the same thing as 4xy multiplied by what? So what am I missing? I'm saying 4xy by something is going to be 8x squared y. Well, it's 2x. And why is that? Well, 4 times 2, that's how I get 8. I have xy, but I need x squared y. So I need to get another x. So that's why I have an x in here, because that x by x is x squared. What about 4xy by something is going to be 12xy squared. Okay, the number 4 by what number is going to be 12? Well, it's going to be 3. Yeah? And okay, I have an xy squared here. I only have an xy. So what am I going to multiply by? 3y. Because 4 times 3 is 12. And I needed another y to get, because y by y is y squared. Okay. Here's the recap question. You can have a go at it. So, first part, find the highest common factor of the coefficient. So, what's the highest common factor of minus 3 and minus 15? I said 3. Now, you could have chosen minus 3 technically, but 3 is also valid, so I'm going to pick 3. And what's the highest common factor of the variables x squared and x? Remember, x squared is just x times x, and x is just x by itself. So the greatest thing I can divide both of these by is x. I could divide this by x squared, but I couldn't divide this by x squared. So the greatest thing I could divide both of them by is x. So the highest common factor of this is going to be 3x. Now, if I were to write them in their factorized states, well, it would be minus 3x squared is equal to, okay, first look at the number, or the coefficient. I have 3, but it needs to be minus 3. So I'm going to say, well, it needs to be minus 1, because 3 by minus 1 is minus 3. Remember, if I write minus x, that just means minus 1x. We don't bother writing the 1. Okay, well, it's an x squared, and I only have x over here, so it's going to be x. So minus 1x. Minus 15x, well, that's the same thing as 3x. Now, they both have x's, so that's okay. But it's minus 15 and 3. So I need to multiply something by 3 to get to minus 15. Well, it's going to be minus 5. Because a plus by a minus is a minus, yeah? Okay, that's the end of the video.